Question number 10 shows the values of two variables x and y obtained from an experiment data. Two variables x and y are related by this equation, non-linear equation, such that a and b are constant. So construct a table for the values of x, y, xy. That means this one we will copy, we can use back. The big Y is there, so that means we have to multiply xy. This will be our big X. Alright, we just multiply. If we multiply carefully, we will take this one time. This one is 7.64. It must be 2 decimal after rounded off correctly. So we can create a table like this. This is a Y, and then we come out with a new column with the xy. This is big Y, which is this is big X, which is xy. So we multiply one by one. This is 26.57. This one is 4.43. We multiply 13.3. We get 58.92. And then 10.13 times 8.9, we get 90.16. And then these two we multiply, we get 114.85. And lastly, we take this one time this one, we get 150.18. Must be 2 decimal places. That's about table. For the graph, let's see. Alright, now for you to plot the y against xy. Using scale of 2, it is a must to follow the scale 2 cm to 20 unit on the xy axis and 2 cm to 2 unit on the y axis. Right, xy we use 2 cm to 20. This is a big X, this is a big Y, 2 cm to 2 unit. Okay, hence draw the line of best fit. Right, so the line of best fit must be having the point that is balanced up and down. Right, so that is line of best fit. Then use a graph from 10b to find the value of the A and B. And then another method of getting the straight line from the graph for the above. Okay, so there's another method. We have to use a graph. Alright, so we will use a graph to find we draw the graph, we get a straight line, we find the gradient and find the intercept. Then we will solve the constant, and then without drawing the second graph, calculate the y-intercept of the graph. Alright, so that means we actually find the gradient and find the find the y-intercept. So we start with a non-linear equation here, xy minus yb equal to a. Okay, xy minus yb equal to a. If we look at our equation just now, we have the xy here, right? We have the y here, right? We have the 21 here. We have the m, which is equivalent to negative 1307, right? Okay, that is our gradient. So that means based on this, we will express our y as a subject. We factorize the y, so become x minus b equal to a. That means, okay, so we have to follow the graph xy minus. So that means we have to express YB as the subject, so YB. So that means my Y is I divide by B divided by B divided by B is 1 over B XY minus A over B, right? So let's see. If I cancel out here, alright, so the simplest one is this is 1 over B. Alright, so this is a gradient. This is a y-intercept, right? Okay, still remember just now from the graph, our gradient here 0.92 and then 13.3. So you need to find the gradient by using these 2 points, this one and this one. So m is 21 minus, always use y2 minus y1 over x2. You start from y2, you must start from x2, 58.92. So make sure the answer must be 4 significant figure. Alright, and then if the line is going down, so the gradient should be positive, should be negative, right? Always use common sense, double check. Okay, it should be negative. Okay, we try to write in 4 significant figures, so it's negative 0.13. Alright, so 21 minus 13.3 over negative 58.92. So we get the answer is negative 0.1307, right? 0.1307. So we have two main objectives. After we draw a line of best fit, we must find the y-intercept. C is 21 and the gradient is negative 0.1307. Right, so this is must be 4 significant figure. Alright, so we use these two to solve the constant. That's all my sharing about the line of best fit. 21, so that means this value will be equal to 21, and the gradient we got the negative 0.1307. So that means we have to write down 1 over B is equal to negative 0.1307. Hence, B is 1 over negative 0.1307. Let's plug into the calculator. Negative 1 over 0.1307. So we will get the answer is negative 7.6511. 7.6511. The answer varies, depends on the gradient of the graph. Alright, so long as your answer is negative 7.7 something, is okay. So this is the B, and then for since we got a B already, we can use the B to solve the A. Alright, so we will substitute the negative A over B equal to 21, and then we'll use our B just now, which is 21 times with negative 7.651. So that means our answer for the A, the constant A, will be positive, because we have 2 negative, cancel out the 2 negative, right? It become positive. So it's 21 times with the answer, which is around 160.67, right? Right, so double check, 160.67. So if you round off too early, it will affect the answer. 160.671, almost the answer, right? That is one why the A and B will affect the answer, because our value of the B is negative 7.65, So the A is 160.67. So we have solved the A and B by reading the gradient and the intercept of the graph, and then we compare with the constant. So that's all how we solve the graph. And then there is one more portion of the graph. We want to find the part D. Another method of getting a straight line graph for the above nonlinear equation is by plot 1 over y against x. 1 over y against x. Alright. So without drawing the second graph, calculate a y-intercept for the graph. So we are not supposed to draw the graph. So we will go to this equation. We will modify the equation. Here, it will become, we have to make it 1 over y. So that means we have the y, x minus b equal to a, right? So if I'm going to write like this y I bring over. So that means 1 over y is equal to 1 over ax minus b over a. So that is how we find the c is negative b over a. So we can substitute c is negative b over a. For the D, for the part D, c is negative. Okay, we just substitute c is negative. What is negative b over a, right? We have the negative b over a. Okay, this is our new y-intercept. Negative b over a. Our b is, we just inverse the answer, right? So that means just 1 over 7.65. Just now our answer is what? 7.65 something, isn't it? Okay, the answer that we got from the graph. Okay, let's see. We just inverse 7.65, right? So our answer is a bit different. Use the data. That means we don't have to draw the graph. Now we want to find the c-intercept will be different with the just now the graph. So you just take the answer. You will get the answer, which is negative b over a is our gradient. Is it positive? Okay, a is our a is 160.67. Our b, okay, let 1 over b. Where is the b? Okay, 1 over b, negative 7.65, right? So there is a negative 7.6. This is negative. Okay, so we have 7.65 divided by 160.67. So we get the answer, which is 0.0476. 0.04761. So this is the y-intercept that asking by the question. So the y-intercept is a c. Your answer may be a little bit different from the one that I used. 0. Okay, we want 4 significant figure. This is based on calculation. We didn't draw the graph. There's another graph, in fact. Right. Now I'm going to show you how to plot linear graph, line of best fit. So how they give mark is based on your axis. Axis must be correct, and then all the points, all the 6 points must be plot correctly, 6 points, and then you must draw the line of best fit. The line of best fit, still remember? Alright, so let's have a look. So normally when we want to draw the line of best fit, we will try, okay, first of all, you have to make sure the axis label, okay, this one must label correctly, XY here, this is big X, and it must be always start with 0 here because we need a y-intercept. It is a must, compulsory. Alright, for the X, it is a must. For the Y, depends. Okay, so you have 20, 40, 60, 80, 100, 120, 140, and until the last one, 180. For the Y, big Y, we have 2, 4, 6. We need to follow the scale, and then it make sure the scale is uniform, 10, 12, until 16, 18, 20, until 22. And then we plot the point correctly. So this is the point that below the line, this point. So I just highlight to you the point that is a point. Okay, the point must be accurate. Right, this is the point. One below the line, one above. Is balanced. And the distance here, make sure the distance is almost near to the line, and the distance must be balanced. So we have 1 point above, 1 point below, and then this point is exactly on the line. This point is below the line, so we should have another point which is above the line. Okay, so it's balanced. Alright, so we have 2 points on the line. We have 4 points not on the line, but they are balanced by the straight line up and down. So that is called the line of best fit. So you will be given 1 mark based on that. Alright, then after that we will have to find the most important is a y-intercept here, which is around 21.0, and then we have to find the gradient for the straight line. For the gradient, we will use a point that lies exactly on the line. We can consider this point, or maybe this point, or we can use the y-intercept. Alright, the y-intercept is a good point to use, which is 0.21. Alright, so we can find the gradient by using 0.21, and the other point that exactly on the line. So maybe we try to find the gradient from the graph. This point is at 13.3, right? This is 58.92, and then 13.3. So you need to find the gradient by using these 2 points, this one and this one. So m is 21 minus, always use y2 minus y1 over x2. You start from y2, you must start from x2, 58.92. So make sure the answer must be 4 significant figure. Alright, and then if the line is going down, so the gradient should be positive, should be negative, right? Always use your common sense, double check. Okay, it should be negative. Okay, we try to write in 4 significant figures, so it's negative 0.13. Alright, so 21 minus 13.3 over negative 58.92. So we get the answer is negative 0.1307, right? 0.1307. So we have 2 main objectives. After we draw a line of best fit, we must find the y-intercept. C is 21, and the gradient is negative 0.1307. right? So this is must be 4 significant figure. Alright, so we'll use these two to solve the constant. That's all my sharing about the line of best fit. Till then, bye bye and have a nice day. Make sure it's labeled with Y. Okay, make sure all the points are accurate. Big X, and here must be. It is a must to start with a 0 for the x-axis. Be careful. Bye bye.